Good afternoon, everyone. Thanks very much to attend this session. So it's about an open source project named Apache Eagle. So first of all, please allow me to have a brief introduction about us. My name is Hao Chen. I'm now the PMC member and also committer of Apache Eagle and work for eBay as a software engineer. This is Ralph Su. He's also the PMC and the committer of Apache Eagle. Okay, in today's session, we include about three parts. The next part is the Q&A. So first, we have a brief introduction about the background. What's Apache Eagle? Why we build Apache Eagle? And what can Apache Eagle do for the customer? And the second part is the main part about the technical dive and about some architecture and some design idea. And so the third part is the case study. It will provide some typical use case we have adopted in eBay and also in the community. So what's Apache Eagle? Apache Eagle is a distributed real-time monitoring and alerting engine. It's spec for big data system like Hadoop. It's now open sourced as an Apache incubator project since last year. As the first capability we open sourced is to monitoring the Hadoop about the security. That is the topic today, secure Hadoop in real time. To be more specific, is a data activity monitoring solution to accidentally identify the access to sensitive data and recognize the attacks and the malicious activities. And also, we are trying to loop the monitoring back to the action. So it may to block attacks or do some remediation actions in real time. So this is the project we will discuss or share with you. So why we build Eagle? So like all of you here, we use Hadoop to drive the business, right? Because we have a lot of data, we wanted to find the value from the extremely huge of data. So in eBay, from the 2007, we have an initial cluster, and as the cluster grows, we have our cluster become more and more large. Hadoop help eBay a lot in the business decision and also help a lot to provide the value from data, but also have some great challenges. For example, firstly, as the data. eBay is an e-commerce company. The data is very critical. So any data put into the HDFS should be highly secured. And also we have to monitor every user activity on the data. And also the platform, we have thousands of jobs running on the platform daily. The Hadoop healthy availability and the performance affect a lot our output, our data product, and also impact the business. Now in eBay, we have more than 7 clusters and thousands of loads and hundreds of PB of data. And as to the monitoring for us as an infrastructure team, yeah, we want to monitor to make sure this data are secured and make sure the clusters are healthy. We have to monitor the events, metrics, jobs, and logs. So the monitoring itself become another big data problem as well. So we built the Eagle because the existing solution may not help a lot to handle such a huge monitoring data. To be more specific, the core challenge may be included the large-scale processing and the storage. So first of all, we have a very high throughput of logs, metrics, and the events. We have to process in concurrent way or distributed way. And secondly, we wanted to define the monitoring policy. Policy is a monitoring rule. We name it the policy. the policy may have a lot of logic, and we wanted to make sure the policy is flexible to be defined and is very easy to manage. The managing includes to deploy it, restart it, or disable it. Okay, and also we have processed data. We wanted to store some valued data. We wanted to we may store the road log, but we also wanted to pass the log to get some event or the metrics. So we wanted to resolve the storage issue here. And also, besides the basic execution, the physical computation problem, we wanted to resolve the alerting. So alerting, we want to make sure is real time. The real time includes different of parts. The first, we wanted to collect the data in real time. We wanted to process the data in real time. We wanted to define the policy and evaluation the alerting model in real time. So the third part is we wanted to, in existing solutions, we have a lot of monitoring solutions, right? It provides a very simple threshold-based monitor, the alert policy or the rule. But in Eagle, we wanted to resolve some problems that is different. And sometimes it's very complex. So we wanted to make sure our engine can express a very complex correlation model. And like it may be some threshold, definitely we will cover the existing monitoring solution have provided. We also wanted to provide the string join and the window and so on. And more important, we think the predefined policy may help us to alert some bad things efficiently, but we think the machine learning will provide will identify some things that cannot be declarative defined in policy. Okay, more important, in Eagle, we care about the monitoring alerting model more than the physical execution engine. So we think the business logic, like here, is Hadoop monitoring. Every company may have their own monitoring system and may have their own monitoring logic. But in fact, I think most of the model can be shared and can be reused. So this is the first problem we want to resolve, the Hadoop ecosystem integration. It includes the alerting modeling and also the data source integration and so on. So based to resolve the, because faced of this challenges and we wanted to resolve the problems, so we try to build an ecosystem. It may include, consist of 4 parts. In the core part is the Eagle framework. It provide some common components to develop some scalable monitoring applications, and we also build some building logics, including the alerting model and also the data integration and so on as the Eagle apps. So typically here is the Hadoop. We may also integrate with the HBase, Hive, or Spark, and also in eBay, we may extend it to the cloud, to Docker, and so on. And the interface. In Eagle, the system seems, in fact, a lot of companies are using the same technical stack as we use in eBay. We wanted to monitor in the clusters in real time. So we leverage existing streaming engine like Storm, Spark Streaming, and so on. But which makes the whole architecture very complex. So in Eagle, we want to standardize this and provide a very extremely simple interface. So the first part is the REST API. It will contain some metadata. We want to describe the complex architecture in very simple metadata and API. And also we want to provide a registerable management UI for different applications. And also provide some basic visualization solutions. Okay, and the integration, as just we mentioned, we want to, the initial problem we want to resolve is integrate with Hadoop. Here in Eagle ecosystem, we want to expand our scope not only to the Hadoop, also extend it to everything we want to monitoring. And by the default, Eagle will focus on the framework development and also provide some built-in applications and alert model. Okay, now in eBay, we have covered 7 clusters and more than 10,000 of loads, and handled millions of data per day, and the latency is very slow, very small, less than 50 million seconds. So the efficiency is very good basic. So the following we have a brief introduction about our architecture. The rough rule will have some technical dive part about this.
Oh, thanks. Hi everyone. This is about this is the overview of the Eagle overall architecture. So by product, Eagle is a monitoring system that it is try to solve the similar monitoring system to all the distributed systems like Hadoop and other distributed systems. So basically, it has a data ingestion layer. That is, currently we are ingesting all the audit logs and the query logs and MR job logs, and even we have some jobs in progress that try to ingest the Spark job logs. We are using a couple of data collectors, like we are using log status to collect a nano GC log, and we are writing some feeder, myself using Java code to collect like HDF log and the job logs that inside in HDF. So all these are collected and put into a Kafka bus. So basically here, and later on, these data will be loaded into a key component in real-time stream processing. We call it distributed policy engine, which we will get into detail more later. And after this data stream being processed, the data will be going to the external storage. So currently, we are mainly using the our storage solution on top of the HBase. And later on, we will discuss on the HBase low-key design. And also, we are investigating using the Druid to store the metrics, so that the Druid to rely on the Druid's roll up and quick query and aggregation from the Druid. So we are talking about this distribution policy engine, but all his behavior, it is driven by this Eagle web service. So that is, we are defining all of the metadata, that what kind of data stream would come in, and how would that data looks like, and what kind of policy we are going to do on that. So all these are defined in Eagle web service, and will be drive this policy engine to run, and will also be some kind of UI and based on this web service. And besides all these common monitoring systems we have, like in other monitoring systems, we are also building some kind of machine learning library, and how we will later introduce some kind of interesting case that we are using machine learning to do, like user profile for Hadoop user. And the last part is that by having these Eagle web service, we are able to have external integration. Currently, we have in the community, we have users that they are integrated Eagle with data classifiers and data guides. Okay, so we are going to get more detail about this core component of a policy engine. Yeah. So here, so basically, this policy engine is real-time streaming processing. So we adopt Apache Storm as our default executing engine, and of course Kafka as our message bus. And the core concept here is that what kind of rule or policy user can define on top of this policy engine. So basically, we are providing CPU-like CPU streaming that will be evaluated on top of the storm running, and to make this policy declarative, so the user can simply add or delete some kind of policy, so that it could be easy to Hadoop administrators easily change some kind of a policy to to monitor the whole Hadoop clusters. And we will also talking sample scalability. There is an example case that we see in eBay that there's how we do this to handle the scale. And the last one will be about the metadata related to this policy engine and how our design principle and behind that. So here's a simple example about the policy engine. Basically, it is a define a string and with some kind of filter and some kind of like expression evaluation, and then say, I'm going to do some projection and insert to some kind of output string. A more detailed policy looks like so. Basically, we are relying on the CDCP. I think it's not showing here, but anyway, CDCP, it is open source CDCP engine. So we don't re-event this evaluation engine because we find that the CDCP actually support a bunch of features that we need. So for example, like typical filter and join in the CQ select in CQ, and they also support like group and heavy. So this and all the aggregation information. So that will be this group by function will be quite useful when we try to classify these clusters and try to calculate the max CPU or average CPU or the average capacity usage. So all these rules will be run on top of assembly storm boats. So that is the data streams come into the storm, and when the data stream came to we call it alert executor, and we will try to instance this CP evaluation and evaluate data based on this. So these are the production case that we are using in eBay to monitor our Hadoop class. So the first one is some kind of symbols that we have a data collector that will calculate the Hadoop name node from the Hadoop name node GMS matrix, which will calculate the capacity usage, and the value will be like normalized to 0 to 1 float, and then we do a simple threshold check on this data. And the latter one is some kind of complex. Is that we want to detect whether the name node HA state have switched in a couple continuous a couple of minutes. Typically, this will mean that the Hadoop system is in some kind of incorrect status. So basically, we are using a pattern match here. So notice here, actually we are declare two string and name A and B, and with the pattern match said, okay, if A happen and B happen, and they are happening in a sequence and within some a specified time window, and then we are going to select all about the related state there. And some more complex policy are also being put into the open source Apache Eco, something like the missing blocks. Because for Hadoop admins, it is typical that so if there's a server down, and you will see some kind of missing blocks, and the admin need to try to bring these missing blocks back. And so we put a missing block policy that it could send out alerts, and when there's a missing block, number change. And typically, we are expecting they to be 0, and if it changes to a non-zero, or it is from non-zero, like we have 2 missing blocks, but it is fine. But if this value changes from 2 to 4 or 2 to 10, we'll send out alerts and also send out the missing block IDs. So that this ID will help the Hadoop admin to troubleshooting the system and to try to get those missing blocks back. Okay, so this is about the explanation about these policies. So we have these policies that with the functionality of the grouping and filtering that could help us to do this. So the next problem is the scalability. So I'm taking this one example we made in eBay that, okay, we are doing security monitoring, and we are monitoring about the user accessing HTTPS file. So basically, it is grouping by the user. So but the user uses of the Hadoop, but it's not the same. We have some of the big Hadoop user that we will generate a lot of events, and some and most of them are some rare users. So so if we use the default grouping, that is, we are evenly distributed this from user 1 to, say we have user 0 to 10. So this will cause computation school here. So looking at this table, so before we do this optimization, so we have this load. These load are we get from the storm monitoring, so that these have 10 times of the school that on different boats. So basically, this is typical of the partition problem. So we have a bunch of users with different weight. So our solution is that we will start online calculation of the weight. So we calculate each weight of the Hadoop user we are monitoring. So that so say user 0 will generate 10 times traffic than user 2. Then these two weights are recorded, and will be feedback to this grouping. So that after do this optimization, we have very evenly of the calculation in our internal system. Okay. Okay, this is wording on the security. So this, so we are talking about the functionality and the scalability we did in the eBay, and you know, we know this CDCP it is some kind of powerful, but we want to make it extensible, because there's for a monitoring system very interesting ideas. So can we do some like machine learning? Because we have a lot of monitoring data coming, and the monitoring data should reflect our system status. So we are making this policy engine extensible. So the CDCB is already first citizen, and we also build another machine learning policy evaluator. That is, we will have a machine learning program run offline, analyzing the history data, and will feedback it is decision to our online streaming processing. And okay, sorry. Okay, and now we are going to the for user to like developer to develop an application on top of Storm of Eagle. We are providing some programming API. So actually, Eagle is looks like a library. So you write application based on our API and submit to the system. So basically, what we are doing is that we are translated user-defined DAG to we assign the optimizer rule to a Storm topology, and then finally submit to the Storm. So by this way that there are requirements from communities saying that I don't want to use Storm but I have Spark installed. So I try to run this kind of monitoring application on top of Spark streaming, and we have community that contribution to make this happen. So it will be included in the next release of the Eagle. Cool. So the next step it is about the storage and the query. So I will go through this a little bit quick. So basically, it is that we define like some kind of the OR mapping positioning framework that on top of HBase, so that we are using the in the similar way of like a JPA annotation, so that we have a table or column family, and we support the secondary index. That is, if you specify this index annotation, we will create a secondary index table for that. And the query like this one, so that here is basically, it is actually service here. It is basically a table with some kind of filter, and we support aggregation. So that this will be useful for, there's some morning data that can come into Ebo and stored in the Ego storage. And later on, there could be like a customized UI that the user said, we need a more fancy UI, or we need a more useful UI that could be built based on this service. Okay, this is a simple view about the row key setting. So our row key setting is inspired by the OpenTXDB, but with our enhancements to support more not only the matrix type, but also the log type and the general entity type. So basically, it is prefix, partition keys, timestamp, and also all the tag values there. So this is how we store all the MR job log and the Spark job log inside this inside ecosystem. Okay. So this is this page is a task that we are enhancing our alerting engine, saying that. So we are talking the Ego developer API said the user needs to write some kind of application code based on the programming API we are providing. But there's a typical case that when we onboard in the GMX matrix case for the name node, because if for matrices, we actually usually don't need to do a lot of processing, but rather than, so I have data here, so I'm going to define some kind of a policy. That's it. So we are providing the topology management so that with this topology management API, we can dynamically start a topology or stop topology. And with this coordinator module, the coordinator will decide, okay, I got a bunch of the policy from the user, say they want to evaluate on a given data string. It will locate this policy to different topology and do the data loading and the evaluation as we just described. Okay. And by having this structure of a customized topology scheduler and the coordinator, we can do a bunch of things that are beyond the storm spoil. Likewise, well, we have a data string there, and the user might write two policy because say the first process said group this data string by field A, and the second says grouping this data string by field B. So that is that we have a coordinator. We decided, okay, here's a policy need group A, here's a policy we need group B. We'll schedule them to different boats, and always generating the string loader for that. So that when a policy is located into a topology, it will automatically read the data from there where the policy needed. So all these are declarative. That is, once this system is set up, user just using the metadata API to tell the system what to do. Okay, and here is, and there's some more function that could be provided by this design. That is, we can spawn different data stream from one data source. So that is, for metrics, we are typically saying, I'm going to send all you the CPU memory matrix in one single data topic. But actually, there are two different things because I'm going to write a policy, say, evaluate on CPU and evaluate on the memory instead. But by having this event instruction, we are generating different data stream there, and then policy will be evaluated based on this data stream. And this data stream can also to be like a string join, like we can simply say write it in the CP rules. Okay, and these there are a bunch of details here on this page. That is, okay, we are, so basically this is what is the generic structure of the topology that our topology management module will automatically start it or shut it down. So basically here is the data string event coming, and we are customizing this grouping method. So we are building the data grouping on top of the Stone's grouping mechanism, so that we use a named string to partition the data between the different pods. So we have here's a spot, here's a string rod board, and here's the evaluator board, also named alert evaluator. So in here is that when we ingest data from the even GC log or Hadoop audit log, to make the Kafka work without a hotspot, we possibly make the data randomly partitioned into the Kafka. And later on, if the user say I'm going to write a policy, that it is supposed to use a pattern matching. That means that I'm expecting the data should be came into with order. So we are adding a string sorting here. Basically, it is specify a time window and the timestamp field it needs to sort based on. And later on said if this policy say I'm going to group them by pool or by host, and this string routing module will say okay, for this say 10 storm boats, send the data with the grouping of pool, and for the other 10 storm boats, send the data to them by the different grouping. So that is one data string came in, and there will be different grouping through this storm topology. And okay, and for this evaluator, we just have some kind of similar of the CDCP policy we just described for the before. Okay, so all this, so by having this, actually, user just need to metadata API call to onboard this policy. So this make our the Hadoop admins more easier to add their rules. So actually, this improve the agility of the monitoring. Okay, this is the most complex part. Okay, this is mainly on the high-level architecture and some kind of detail on modules. So do you have any questions right now? Okay, if no, I'm going to hand over to Hao for the detailed Ego use case that are running inside eBay.
Okay, thank you, Ralph. JRF have provided very detailed information and the technology we use and our design ideas. Here we are introduce some use case we use the eBay and also in the community. So first of all is the data activity monitoring. As the subject of this topic, we wanted to scale Hadoop in real time. So physically, we wanted to monitor every activities on the big data system. On the HDFS, user can create a copy or modify. On the Hive, user can access the table or access the column. On the HBase and so on. The second is some performance monitoring. So typically, we definitely have some basic monitoring, some visualization about some metrics. But here we are talking about more about the alert, the monitoring mode, and just the direct visualization. Okay, and also in eBay, so we are building Eagle as the prototype, also the base project to build as the next generation unified monitoring platform. Here we are expand out of the scope of Hadoop or big data ecosystem. So the first use case is the data activity monitoring, which is the open source, the fully open source in the community. So as any big data big data user, big data, some company wanted to leverage big data to find value from the huge of data. They will face the same problem. So as the user have different attributes, it have action and it have zoom, and have host and do some commands, and the command will to effect some file, some have table, or some have column or HBase and HBase table, and so on. So first we may protect the data from loss. Some people may say it's not easy if we have a strong access control, right? But until now, I think Hadoop have a greater have some greater growth on the execution as an execution engine, but the security access control is not good as the execution part. So we may need to monitor detections action, to make sure every user's action on any big data platform to avoid the data loss. And also, as the access control may not very strong, there may some minus login or some unauthorized access. And also some minus user operation, as the attribute of user is complex, and the existing architecture, no matter Hadoop, Spark, or Storm, Kafka, and so on, are not very, especially in the security, is not very good as the main feature. So this is why we build Eagle to secure Hadoop instead of using any existing security project. So currently now, Eagle provides a very easy to use UI to let user to define the policy, to monitoring the HDFS, Hive, and also now we also have HBase and almost all the Hadoop distribution in the ecosystem. And it can cover every attribute and every, not every, but maybe most of use case, most of attributes that a user will do on the system. And you can define the policy to monitor it and detect an alert if some user did something is not expected to do. And also, besides the predefined policy, you can provide some user profile model. It will use Spark to training the historical user activity and integrate with the real-time action in Storm and detect an alert if the user is not act like what he should be. And another, except the security, and another important part of Eagle is the monitoring performance. We monitoring, as do the Hadoop, we want to monitor the performance of the load, service, host, and also the job. Here we have some introduction about the job. As we have already, we have said again and again, in Eagle, we care more about the model and the integrated model for the use case than the simple execution engine. So this is a very typical one. So here in use case, Eagle will distribute the task venue. As there is thousands of tasks running on Hadoop every day, so we wanted to distribute the load venue on the loads. If certain nodes task venue outstanding, we may identify the load may have some problem, even it's not impact any existing business, but we let the infrastructure team to handle about it. Okay, as the alert flow of the model we just mentioned, any the task venue will reflect on the nominee host. So it will send out the alert, and we also provide the performance drill down analysis. And we also, at the end part, we want to loop the alert into actionable remediation. So here we may remove the load from the cluster and or integrate some existing ticket with the hardware team. Another is the job data skew detection. Job data skew is a very common problem in most company, right? You have a lot of attributes. Any attribute may have the data skew problem. So in Eagle, we provide the data skew detection model. Okay, this is the data detection flow. We provide very detailed information. So if you want to learn more about the Eagle, we have some company resource and also some papers and patents. Thank you.
So we're ready to do Q&A. Any questions? Okay.
Is there any other production usage other than eBay?
Yeah, we did have this. Actually,
we have for the security part, we have some userless data guides. They have a core development in this, and we have 2 committers from the data guides. It's a company to focus on big data security.
Data guys,
and
yes.
also some Chinese company.
Yeah, we have me and Ha came from Shanghai,
as most
and
of our
we have some local companies try to adopt this, and they are extending this beyond Hadoop, like try to do like traditional database security monitoring. Yes.
Thank you.
Okay.
So what is data guys? How is data guys security related to what you guys are doing with Eagle?
Data guys focus on the sensitive data identifying. We are focused on the streaming activity detection. So the data guys will provide the sensitive tag in the user activity, so we can detect the sensitive data is operated. It may be removed or modified in real time. Okay, that's where we work together. Okay.
Do you support other types of logs? Like you only mentioned about map reduce and
sorry.
you only mentioned about map reduce and hide logs. Do you also process like Spark logs?
Yeah,
Okay,
yeah.
so
That's what if you check the source code, we